In today's video I will explain some properties of the exponent or the properties of power. So the first rule is called product of power. So product of power, you have to have the same base. So the same base like a to n times same base again a to m. So you keep the same base a and you add the power n plus m. Example. So let's go with an example here. Same same base like 10 to 4 times 10 to 5. As you see, we have the same base 10. I can use the rule. So keep the same base 10 and add the powers 4 plus 5, which is 10 to 9. So another example, 4 times 2 to the third power. So I have to change 4 to some exponent expression with a base of 2. And as you know, 2 times 2 is 4. So 2 times 2, that's give me the 4 times 2 cubic. And 2 times 2 is 2 square times to the third power. Now I have the same base. I can use the product of power. So it's going to be 2 to the 2 plus 3 equals 2 to the fifth, using the product of power. So now let's move to another property, and it's called power of power. So power of power, for example, I'm going to give you the formula, then we can go with the examples. So a to n and the whole thing raised to m. So you multiply the exponents. So it's going to be a to n times m. An example here. Let's see, we have 7 7 to the fourth power and the whole thing squared. So 7 is the base, and you raise it to the product of the powers, 4 times 2, which is 7 to 8. Let me move this up and have some space. Another example, I don't know, 1/3, yeah, 1/3 square, 1/3 square, and the whole thing to the third power. So keep the same base, 1/3, and multiply the powers. 2 times 3, or 1/3 to the 6th power, which is just 1/3 to the 6th power, because 1 to 6 is just 1, and we can change it to a negative exponent, which we're gonna talk about that rule later. So for now, just leave it as 1/3 to the 6th. And let's move on to the third rule, which called power of product. So power of product, and the rule is, let's see, A times B, and we raise everything to M. So that's the same thing as A to M times B to M. Example, just 1 second, need more room here. So example, 5 times 4, the whole thing to 4th power. It's gonna be 5 to the 4th times 4 to the 4th. Another example, I don't know, 11 times 15 to the 9th power, gonna be 11 to 9 times 15 to 9 as well. And now let's talk about negative exponent. The negative exponent is when you have A and raise it to some negative number M. So you change the negative power to positive, but you do the reciprocal. So 1/A to M. And that actually goes two ways. It goes two ways. If you want to go from A to -1, it's equivalent to 1/A to the M, or 1/A to the M, it's equal to A to -M. So depend on what on the question, you can use the negative power to go back and forth between A to -M and 1/A to the M. And I'm gonna give you a couple examples here as well. So, for example, if I have two -3, so this is 1/2 to the 3rd power, which is 1/8. 2 to the 3rd power is 2 times 2 times 2. So 2 times itself 3 times, and that's give me the 8. So now suppose I'm going to the other direction. So I have 1 over 5 to the second power. So that's equal to 5 to negative 2. Using this rule, but this direction. Now let's move on to another rule. It's called the zero power. So zero power basically just a number that's not equal to 0, a. So a it's not equal to 0. So any non-zero number, when you raise it to 0, you're just gonna get 1. That looks weird because we know some people think a to 0 will be 0, but not. So a to 0, any non-zero number, when you raise it to 0, you get 1. So example here, 2 to 0, we get 1. I don't know, negative 2 or negative 3 to 0, you get 1. So any non-zero number, when you raise it to 0, you get 1. Another rule is called the quotient rule. So the quotient rule, when you have fraction, for example. So the rule is, but you have to have the same base. So a to m over a to n, and here a must be not equal to 0. So you get a, and you do the difference of the exponent, m minus n. But a must be not equal to 0 because it's in the denominator. Example, 10 to the 5th power over 10 to the 2nd power. So 10 is the base, and you subtract 2 from 5, and you get 10 to the 3rd power, or 1,000. So 10 here to the 3rd power is 10 times 10 times 10, 3 times. Another example, let's see, I have 3 over 3 to 2nd power. So I have the same base. So 3, that's mean 3 it's raised to the 1st power. So there is a 1 here, but we're not writing 3 to the 1st power. We just write 3. So you get 3. Let me get rid of this. Yes, so 3 is the base, and you subtract 2 from 1, so you get 3 to negative 1, and again using the negative exponent, that's 1 over 3. And finally, let's talk about the power of quotient. So power of quotient, For example, you have the rule is a over b, and again b is not equal to 0 here, and you raise it to n, so that's the same thing as a to n over b to n, and b of course not equal to 0 because it's in the denominator. Just 1 second, need more, I think, need more space here. Give an example. Let's see, we have 5 over 2 square. So that's 5 square divided by 2 square, which is 25/4. And again, 5 square is 5 times 5, which is 25, and 2 square is 2 times 2, which is 4. Another example, just to be familiar with the rule. It's not difficult, but you just have to make sure you're using the rules properly. So the second example, let's see, we have 10 over 9, the whole thing to 5th power. So that's 10 to the 5th over 9 to the 5th. And if you want to simplify it, you can use your calculator and multiply 10 by itself 5 times, and multiply 9 by itself 5 times, and you simplify it to a fraction. So yeah, so these are some of the property or the most common properties of exponent. I hope this video will help you understand exponent very well, and thank you for watching, and see you next time.